Hello, class. Today I want to go over the lab that you'll be doing for this week, week 6. And so, because of the mix up with the ordering of the kits and getting the right supplies, I am moving up week's 8 lab to this week. And so, I want to go over what you should have for this particular week's lab, and then I'm going to go through the instructions. So, you should get something that looks like this. Probably came in something that looked like that. Okay. And so this has your instructions on it. It also has some background information on here and the instructions on the back. These are your charts so you can match the colors and find out what the concentration is of these different parameters within your water that you're testing today. And so this is the chart that came with all these little packets. Okay. So you should have one for free and total chlorine, or two. There's two of them in here, two strips. And then you should have nitrate and nitrite test, the Johns copper test. You have the Ida's iron test, and you have the pH total alkalinity, and then the total hardness. I have two of them, but I already took one out so you can so I can show you. All right, so the strips look like this. And you have two strips each, but you're testing for water samples. And so what you need to do is just cut this in half, okay, so that you can test each of your samples. You should have 4 plastic cups. You should have a Sharpie and a graduated cylinder, 100 mil graduated cylinder. Those should all be within your kit, okay? What you need to get is you need water samples, okay? So this is tap water. That's one of your water samples. Bottled water is the other. Rainwater is the third one. And the fourth one, my nail polish went off, but the fourth one should be pond water, okay? Pond or lake, whatever you have in your area, okay? And so you want 4 different water samples that you're going to be testing. That's what's going to go in the 4 cups. And it says you're going to measure out 200 milliliters. And so I am going to put on, even though this is water, we want to make sure that we are staying safe. You can wear your vest as well. Okay. But I'm going to take, excuse me, my tap water. Okay. And you're going to pour it into your graduate cylinder. You can see, ooh, you can see the 100 mil mark is right there. So you want to measure out enough of your water to get to the 100 mil mark. Okay, you can see it going in there. And we're going to go all the way up to that 100 mil line. Okay, all right. And once you do that, you are going to pour it into one of your plastic cups. And you need 200 mils. And so we're going to measure out another 100. Okay. So we're going to pour that in there to measure out our second 100 mils. Okay. Just a little less. A little bit more. Oops. I was a little over. Got excited there. Okay, let's try this again. All right. And then again, you pour that into your cup. All right. And there you have it. For the test for chlorine, it does say do 500 mils, which doesn't fit into your plastic cup because only 200 mils, as you can see, fits in there. So you can do 200 mils for the chlorine test as well, right? And so we're going to take our total hardness strip And like I said, because we have two strips and you need four, we're just simply going to cut this in half. You need a pair of scissors. All right. And it says for the total hardness, okay, if we look on the instructions, this is on your sheet, it says you want to dip one strip into the water sample for 3 seconds, remove and immediately match color for total hardness. All right, and so 3 seconds. So you can do a timer, okay, for your 3 seconds. I think I'll do a timer to make this accurate. Okay, so if you have a timer on your watch or your phone, that works perfectly. All right, so we're gonna do our 3 seconds because we want this to be accurate. And then we'll have our color ready so that we can match it immediately after our 3 seconds. All right, so 3 seconds. Mhm. And we're gonna start. All right, so we're just swirling it around in the cup for 3 seconds. All right, and I don't get a color. It was my 3 seconds. Immediately match it. It doesn't match to a color. Ooh, it is wet. I wonder if oh, it's this that matches. Okay, I was matching the wrong thing. It's that little thing, so cutting it in half won't work. All right, so we immediately match it to the color. All right, so let me show you. All right, so I might have to change that. I wonder if you can change that. All right, so it looks like it matches that one. You see that? Looks like it's closely matching that one. All right, so if I read that chart, then that says that it is 50 ppm and 3 GPG. All right, so that is soft water. So my tap water is soft water. That's pretty good to know. All right, and so now let me show you the chart. So let's share this. Okay, so we're gonna share this screen. Share. All right, so where you find this, first of all. So we find this on the under week 6, the instructions updated. So that's where our instructions are. And so we want to bring up the instructions so you can see it. All right, so it gives you an overview and the outcomes, so forth, the background information about your water. All right, and then some background information about the different tests that we're doing, the materials that you have, your cups, graduate cylinders, your permit marker. Okay. And then your safety for this. So you wear your goggles, like I showed you, your gloves, especially when you're working with pond water and rainwater. I was just working with tap water, so I didn't have the gloves on or the apron, but those are your safety precautions for this. And you want to read all the instructions before you get started. Make sure you have on the proper PPE. Make sure you're not eating, drinking, or chewing gum while you're doing this activity. You want to make sure you wash your hands with soap and water before and after each activity. You do not want to contaminate your samples, nor do you want to contaminate your hands after the fact, okay? You want to keep the pets and the children away from your lab materials and equipment, okay? They can watch you do the lab. This one's a pretty safe one, but those are general safety rules that I like to post. but your children can watch you do this lab. This is a pretty safe lab for your children to watch, and it's kind of cool to see what's in your water or testing your water since we're doing tap water is one of our tests. Okay. So the preparation, you want to read through the activity, obtain all your materials, clean and sanitize the workspace. Okay, very important on that cleaning and sanitizing. And we've done this for all our labs, so you should already have the sanitation materials or substances that you're going to use to sanitize your area because you've done that for previous labs, so you should still have that. So we want to do the filtered water, the tap water, rainwater, and the pond water. And I'm going to see if we can reuse strips because I was thinking, but the test part is at the bottom. So I'm going to see if we can reuse it. Let's see if we get results from that if we reuse the strip. Then let me do it real quick, see if that works. And no, no, yeah, that kind of works. So try it. Try reusing the strip. See if that works. If it doesn't work, then I'll know to order two of these in future kits. Okay. But we're going to try that for this one. All right. So then you want to look at the different tests that you're going to be doing. Once you've done those tests, you want to go through disposal and cleanup. And then I'll go through the charts with you and the rest of the information. So the disposal and cleanup, the used test strips can be disposed of in the household trash. Water samples can be poured down the sink, clean and dry the cups, and return them to your equipment kit. Okay, and so now we're going to look at this data table. So you're going to put the color and the concentration for each of these. And here are your EPA standards for tap water and filtered water. These are your EPA standards. So you can see how close you are to EPA standards. So my hardness was 50. Okay. So my hardness was 50 ppms. My color was kind of like a creamy brown color. So I would put creamy brown. And then for my concentration, it was 50. And you see EPA standard is 500, okay, which is very hard water, right? So I am below EPA standards. No, sorry, this was my tap water. Creamy brown. So be careful of this that you put it in the right category. Here we go. All right, so you would do that for all of your different substances. So if you find that the strips don't work for, excuse me, twice, then you definitely want to do the tap water. And then you'll choose one, either pond water or rainwater for your second test. So if you don't have all four waters tested, it's okay. You'll at least have two out of the four. Okay, so that's perfectly fine. I'll know that when I'm grading it. All right, so then we get down to calculations. So we're doing the hydrogen ion concentration from pH and water quality, including ppm conversions. So this is to give you some exposure to doing calculations to see how these values are come about. So we're looking at pH. So I want to do the pH test just so that I can show you how to do the calculation. Okay, so I'm going to take one of my pH strips out. Okay, all right, so we have pH and total alkalinity. They are on the same strip. I don't know if you can see this. Okay, the test for both. All right, so we want to put this in our water. And we're going to stir it around. And we are doing pH and total alkalinity. We do for 10 seconds. Okay. And then match color for pH. Then match the total alkalinity color before 30 seconds have passed. All right, so the pH looks like my pH is 6 point, no, it's more of a 7. And total alkalinity is 80. So let me show you this. All right, I'm gonna stop sharing so that you can see this. All right. All right, so if you look at this, looks like it matches the 7.0 and the alkalinity. Or now it's kind of looking like that. No, it looks more like that. All right, so it looks like the 7.0 and the 80 for the total alkalinity are what's matching. Okay, and so we will go back to sharing. Okay. All right, so then for my pH, tap water, my color is like an orange color, and the concentration that's 7.0. And then for my total alkalinity, it's kind of like I would say forest green. And the value for that is 80. Okay, so now we're going to go down here. And so this information is to help you learn about pH. So when you have these square brackets around H plus, that represents the concentration of, okay? Those square brackets mean the concentration of. So the concentration of H plus from pH values is what we're going to calculate. We want to convert the concentration of H plus from moles per liter to ppms. So we're going to do that first, and then understand how pH and hydrogen concentration affect water quality. Because if we look back at our standard, oh, we don't have a standard for that, but our standard, our EPA standard for pH is between 6.5 and 8.5. So our value of pH is within the standard. So that's a good thing. All right. So now for explore how contaminants can change water pH and make comparison across water samples. And so when you test either your pond water or your rainwater, you'll be able to see how those two waters change the pH. Okay. All right. So pH is the negative logarithm of the hydrogen ion concentration. So H plus concentration is equal to 10 to the negative pH. And pH, which I didn't put that here, I didn't put the equation. All right, so let me put the equation here so you can see it. pH is equal to the negative log of the H plus concentration. Okay, so that you have that. And I will update the worksheet so that you see that equation. All right. And so then if we're finding H plus concentrations equal to 10 to the negative pH. So our pH for our example is 7. Okay. So with the pH of 7, then 10 to the negative 7 is our H plus concentration. So the molar mass of H plus is 1.008 grams per mole. So to find ppm, we take our H plus concentration, which is in moles per liter, times 1.008 grams per mole times 1,000 milligrams per gram. And so ppms is basically your H plus concentration, which in our case, I'm going to do it right here so you can see it. ppm is equal to, so our H plus concentration is 10 to the negative 7, because that's our pH. Okay. And put this in parentheses. And we're going to actually say 1 times 10 to the negative 7. And I'm going to show you how to do this in your calculator. That goes up because that's a superscript. And then times 1.008. Oops, no, not 9. And then times 1,000. Okay? And that's going to give you your ppms. All right? So I'm going to show you that on the whiteboard. So let me copy this down and then I'm going to switch to the whiteboard so you can see it because I want to make sure that you understand this calculation and how to put it into your calculator and how I get all these numbers. Okay. Then we're going to go through the examples that are actually in this lab. So I am going to stop sharing for right now and I'm going to bring up the whiteboard. And bring up a new whiteboard. All right. And so now I need to get, okay, a pen. All right. And I've got it in black. Awesome. All right. So let me just rewrite what we have. So we have a pH. My writing is not the best on here, but you get the idea. So our pH is 7.0. That's what we measured for our particular water sample. So to find our H plus concentration, we take 10 to the negative pH, which is just 10 to the negative 7. Okay? Now, to find our number of ppms, ppm means parts per million. And this is important because a lot of the measurements that you do in water treatment as well as in wastewater treatment are in ppms. Okay? That's our That is what we use for concentration, is parts per million. And so we take our value we got for H plus, which is 10 to the negative 7. You can keep it like that. I know I said 1 times 10 to the negative 7, but you don't have to do that. We're going to multiply it by our molar mass for H plus, which is 1.008. And then we're going to multiply that by 1,000, and that's just to change our grams to milligrams. All right. And all of those will give us our parts per million. All right. So how do we do this in the calculator? All right. So you should have, or you will need a scientific calculator. Okay. And so in the scientific calculator that I have, this is a Texas Instrument. Okay, you can see that. All right, and you don't have to have a Texas Instrument. This is just one of the more common ones that you see. You can get these at Walmart. Dollar Tree now starts selling scientific calculators. It's not a Texas Instrument, but it is a small scientific calculator. So you don't have to spend a lot for these. You don't need a graphing calculator, not that extravagant, but you do need something that says scientific calculator. Okay, so there is a button on here for pH and also for which is your log button, right? Because remember, pH is the negative log of your H plus concentration. And so you should have a button that says, and hopefully you can see it up here at the top that says log. The button above it says 10 to the X, which is your this. It's the inverse of the log. So it's your H plus concentration. And so if we wanted to find the H plus concentration, 10 to the negative pH, you would use that 10 to the X button. And so it is a second button. So it gives you 10. I don't know if you can see that on the screen, but it's 10 and then there's a little caret. And then you put the negative value of 7. So you put -7. On the calculator, there is a negative button. You don't want to use the minus sign because that doesn't mean negative. That just means subtraction. But there is a negative button on your calculator, and it's generally in parentheses. So it generally looks something like this, or sometimes it looks like this, okay? Either one of these, that's your negative button, okay? So once you do 10 to the -7, it gives you, if you can see it, there you go. See a decimal with a bunch of ones, okay? So then you want to multiply that. We're doing this part down here. You want to multiply that by 1.008, and then you want to multiply it by 1,000. And then what you get for our ppms is 0.0001008. Okay? And that's your ppms. Okay? Now, if you'd like to, you can change that number to scientific notation. To change it to scientific notation, if you're doing it the paper way, you take where your decimal is and you move this over until you get it to behind the first non-zero number. So then your new number becomes 1.008. Then you're going to put times 10. Your exponent for the 10 is the number of spaces you moved it. So we moved it 1, 2, 3, 4 times. All right, so it's times 10 to the fourth. But because our original number was less than 1, then our exponent is negative. All right, if our original number was greater than 1, our exponent would be positive. Okay. And that's ppms. All right, but either answer would be perfect. All right. So now we're going to look at, all right, so we're going to stop sharing the whiteboard. I remember how to do this. I think I just, yep, yeah, there we go. Stop sharing the whiteboard. We're going to go back to our screen and we're going to look at our directions. All right, so we've done this calculation. All right, I'm going to erase that. All right, so, oh, I erased too much. Undo. I was just supposed to erase this part. There we go. All right, so now here's an example calculation. I want to go over that so that you can see another example. I'll make that a little bit bigger. There we go. All right, so if we have a pH of 3.5, so we're going to do 10 to the negative 3.5. We put that in the calculator. We get 3.16 times 10 to the negative 4 moles per liter. Now, we want to make it into ppm. So we take our 3.16 times 10 to the negative 4 times 1.008 times 1,000. All right, so if we want to put that into the calculator, so before we had it as a decimal number, this number was a decimal, and now it's in scientific notation. So to put it into our calculator, so let me show you how to do that. So we have, all right, so we have our calculator, right? And so we have this button on our calculator. And for my calculator, it's up above here. I'm trying to see it okay, it's an EE button. You also have an EXP button, all right? And so if we have 3.16, all right, so your 3.16, because this EE is up at the top, I have to hit my second button and then this button. You see on the screen how it shows an E? That means it's an exponent, okay? That replaces times 10. So you don't have to put times 10, you just put that button, it's going to be there. Then you put negative 4. Remember, for the negative 4, you're going to do a negative, not the minus, but you're going to do your negative button and then the number 4. Okay? Then you're going to multiply that by the 1.008 and then multiply it by 1,000. Okay? So multiply it by 1.08, multiply it by 1,000. All right? And then it gives you this number. All right? So now we're going to go back to share. Okay. All right. So 0.318 ppms, all right, is your final answer. This solution is acidic with a hydrogen concentration of about 0.32 ppms. All right. So let's go through how do we know it's acidic? Okay. So if our pH is less than 7, then it's going to be acidic. If it's equal to 7, it's going to be neutral. And if it's greater than 7, it's going to be basic. Okay. And so let me go back to the whiteboard. So we're going to stop sharing. We're going to go back to the whiteboard. Nope, that's not what I want to do. All right, we want to go to the existing whiteboard. All right, where we have all our good information here. All right, so we are going to talk about our pH. So if our pH is less than 7, then we have an acidic solution. If our pH is equal to 7, then it is basic. I'm sorry, then it is neutral. Let me erase that. Okay. Mine had gone on ahead to the next part. Okay. It is neutral. And if the pH is greater than 7, then it is basic. Okay. And sometimes in water treatment and wastewater treatment, they use the word alkaline. Okay. Alkaline and basic are the same. So you may hear alkaline, and just to note that that is the same thing. Okay. All right. So now let's go back. Oh, nope. Cancel. Let us close that first, and then let's share. All right. All right. So going back. So now This is our hydrogen ion concentration in ppms. All right, so there's another example. This one I did with our own water, so you don't have to worry about that. So you are going to use the pH values determined in activity 1, and you're going to calculate your H plus concentration based on your pH, and you're going to put it in ppms. You're going to show your calculations in this area. All right, so then table 3, you're going to do the pH, your H plus, your ppms, and whether it's acidic, basic, or neutral for all of your different water samples. So if you don't have one thing you can check is your pH because you have pH kit within your one of your other kits. You can check pH for all of your samples. So you may not be able to check all of the different parameters for all your samples, but pH is one of those things you can check for all. Okay, so you want to make sure that you put that in this chart and check for your pH values and do your calculations for all of these. All right, so the ideal pH for drinking water, 6.5 to 8.5 is safe and recommended range for your drinking water. If it's too acidic, it can corrode your pipes and dissolve heavy metals. And if it's too basic, it can taste bitter and reduce effectiveness of disinfectants. Okay, and so here's some contaminants that do affect your pH. So your conclusion questions and then your cleanup for this, okay? So you dispose of the water samples down the drain, wash your hands, and clean your lab station after the activity. So what do we want in this lab report? All right, so you're going to give an overview summary, okay, in your introduction. So you're going to make sure that you do that in your own words. Very important. Your materials. I still see some lab reports where you are itemizing your materials. I want this written out in complete sentences within that area. So your material should be in complete sentences. It should not be itemized. I don't want you to lose those precious points for not putting those in sentences. And then you have your procedures, okay? Again, you want this in sentences and paragraph form. All right. You also want to describe the safety precautions and the cleanup procedures within your procedures. Your results. For these results, you have table of data, you have observations, and you have calculations. All of this has to go in your results section. So very important that you do that. For the calculations, there is a way to do calculations within Word. Okay, so you're able to do that. As you could see, when I did it, I just wrote it all out. Okay, we wrote everything out. Sorry, for these calculations, it's pretty straightforward. You don't even need the calculation or the math editor for your program. You can just write it straight out. And then for the superscripts, if you look up here at the top, you have subscripts and superscripts, so you can always get all that changed. So I do want to see your calculations typed within your lab report. Your discussion, you have these questions that you are discussing in your discussion section. You also have some questions, some conclusion questions. Those have to be included in your lab report as well. Very important. And I don't want you to just list the question and answer it. Your answers to these questions should be complete sentences that you write in paragraph form for your discussion section. Okay, very important. And then your references, you're going to reference this worksheet, obviously. Okay, any other references that you use, you're going to reference that as well. Okay. If you have any questions, tables, remember, tables can always be copied and pasted into your lab report. You have 3 tables that you're doing this week, okay? So data table 1, 2, and then down here you have data table 3, okay? Make sure all 3 data tables are in your lab report. If you have any questions as you're going through the lab or as you're writing your lab report, please let me know. Enjoy the lab.